Hello students, in today's class I will explain some more applications of Newton's second law of motion. Yesterday nearly 5 applications are completed and today see the 6th one. If a gravel is dropped on a conveyor belt at the rate of dm by dt, extra force required to keep the belt moving with velocity u. So conveyor belt means you can imagine like this. Consider these are the two pulleys like a wheels. On these the belt is rolling. Okay, continuously the belt is rolling over these pulleys. Then it is moving with some velocity, initial velocity. That velocity, let us consider it as u. A gravel is dropped, that means consider like a sand is dropping on this belt. That means at what rate means that is dm by dt. So let us consider a 0.01 kg per second or 0.1 kg per second. The mass is dropping on this conveyor belt. That is the meaning of this dm by dt, rate of change of mass. Then now also to move with the same speed some additional force is needed. Why? Because before dropping this gravel it is moving with u velocity. Now the mass or weight is increased, right? So additional force is needed. How much force is required? That is F equals, you know that, dp by dt. Then F equals dp means m into v, or here initial velocity is u, divided by dt. Here this is to be constant. It has to be moved with the same speed. Hence I will take outside. So u into dm by dt. So this much of force is needed to keep the belt moving with velocity u. So remember these formulas. Suppose in competitive exam they may give numericals in place of dm by dt like that. Then directly you can able to apply this formula and you can solve. And in the next application, in next one, in 7th one, a metallic plate of mass m is kept in mid-air. So in this way you can imagine this is a metallic plate. Its mass is capital M. This is in mid-air by firing n bullets per second. That means here these are the bullets firing below from this metallic plate. This bullet is striking to the metallic plate and these bullets are rebounding with same speed. Okay. The mass of the bullet, let us take it as m. So here it definitely the bullets are applying force on the metallic plate, right? That is balancing the weight of a metallic plate. That weight will act downwards. Here in this direction the weight will act. The force acting in this upward direction, right? That is balancing the metallic plate. Hence the metallic plate is at stationary. Then here F equals dp by dt. Okay, from Newton's second law, force equals dp by dt. Then what is the change in momentum? So change in momentum, again you know that the particle moving with some velocity u or v, it is colliding to a wall and it rebounds back with the same speed, means in second application it seems you came to know that change in momentum is 2mu. Then per second means dt you can consider it as 1. Then this change in momentum you got that as 2m u, but how many number of bullets here? N number of bullets. For one bullet, the change in momentum is 2mu. For n number of bullet, the change in momentum becomes 2mu into n, or 2mnu. This 2mnu is balancing, that means that is equals to weight of a metallic plate. Remember this concept. For one bullet, once it will strike and it rebounds, means with the same speed, the change in momentum is 2mu. For n bullet means you have to multiply by n. And in the 8th one, the force needed to stop a body moving with speed u in a distance s. Again, F is equals to dp by dt. Then here a body is moving with initial velocity u. You know that v square minus u square is equals to 2as. So it will comes to rest the force needed to stop means the final velocity become 0, isn't it? The final velocity becomes 0 and the force will act in opposite direction, right? That is nothing but retardation. So that also you can consider it as minus, hence u square you will get as 2as, and s is equals to, or a is equals to, you will get u square by 2s. Now this is dp by dt, this you can write it as m into a also. Then f is equals to m into a. M into a value is u square by 2s. This force is needed to stop a body moving with speed u in a distance s. So remember this formula. Next concept is impulse and impulsive force. Here, impulsive force means a large force acts on a body, a large force acts on a body for small interval of time. Okay, this is called a impulsive force. What are the examples for impulsive force means? You can consider bat hits the ball. Okay. Bat hits the ball, or you can consider hammer hits the nail, and you can consider player kicks the football. So many examples are there, it's enough. These are the examples for impulsive force. A very large force acts for a small or short interval of time. So if you consider this third example, let us consider a football. If a player kicks the football, okay, then there will be a large force acting on this football, but the time interval is very, very small. or an hammer hits the nail, in that time also during contact the time interval is very very less. So in this case, if we want to plot a graph between force and time, so imagine the situation here. Before contact, before the contact between foot and this ball, there is no force acting on this football, isn't it? So force is 0. So as soon as the foot makes contact with this ball, suddenly, initially the force is 0. When the foot comes into the contact, suddenly the force will increases, and this force will last when it lost the contact. That means as soon as the ball again leaves the foot, suddenly the force will become 0. So in this way we will get the graph for impulsive force. So this impulsive force in a small interval of time also, let us take this is t1 time and this is t2 time. In this small interval of time also, the force is variable. The force is not constant. Okay. And here you came to know what is meant by impulsive force, and that is the graph we can obtain for impulsive force. So here you can consider initially before kicking this ball, the ball is at rest. Then what is its momentum means? Its momentum, initial momentum is 0. Once the player kicks the football, then it will move with some velocity. Then what is the, with velocity, let us say take v, then what is its final momentum means? You can say mv is the final momentum. Initial momentum is 0. It is at rest. As soon he kicks the ball, the final velocity becomes mv. What happens here? There is a change in momentum. Momentum has changed. Okay. So what impulse can create means, that means what this impulsive force can create, or what is the effect of impulsive force means the change in momentum. The change in momentum is the effect of impulsive force. The total effect is called as impulse. So here I will write the total effect. The total effect of impulsive, the total effect of impulsive force on a body is called impulse. Okay. So I hope you understood. So that force changes the momentum, that large force acting on a small interval of time, that impulsive force changes the momentum. That is the effect. The total effect on this body due to the impulsive force, or the total effect of impulsive force on a body is called as impulse. Then what is the total effect means? The change in momentum. The change in momentum itself a effect. Then what is impulse means? You can say impulse is equal to change in momentum. Then here I'll define this impulse. So you came on to know one definition. The total effect of impulsive force is called an impulse. That is also right. So impulse we can define like this also. You know that Newton's second law of motion. From Newton's second law of motion, the applied force, external force, is equals to change in momentum, that is rate of change of momentum, delta p divided by delta t. Then what is the value of delta P? Delta P is equals to force multiplied by time. And I said that the force in a small interval of time, that force is variable, not a constant force. Constant force means you can represent like this. So this is the force, this is the time, means as time is changing but force is not changing. But here as time changes the force is changing. This is variable and this is the representation of constant force. Okay, because impulsive force is a variable force and it also acts in very small interval of time, we cannot able to calculate that one. Hence we will consider that force as average. Okay, so let us take this force as average force. So here we came to know that delta P means change in momentum is equals to average force multiplied by delta T. Then this change in momentum is called what? That change in momentum is nothing but impulse. Okay, that effect is nothing but change in momentum. Then this change in momentum is nothing but impulse, and this impulse you can denote by the letter I or you can denote by the letter J. So this impulse is also a vector quantity. So I can able to write in place of delta P J vector. Okay, impulse is equals to F vector, that is average force, multiplied by delta T, time interval. Thus we can define impulse as, okay, impulse is equals to, directly I will write F into T, the product of force and time, the product of force and time is called impulse. Okay, remember, impulse means F into T also. This impulse means change in momentum also. Okay, finally we can write that is this delta P or J, I will write J means impulse. This impulse is equals to product of force into time, that force considered as average force. This also equals to this delta P, that is delta P is nothing but linear change in momentum. Okay, the delta P is nothing but linear change in momentum. So remember this one, this is important. We can define the impulse like this, and this is also called as impulse momentum theorem. Okay, impulse momentum theorem means that J is equals to F into T, that is equals to linear change in momentum. So here one more method how to understand this impulse. How can I derive this impulse? Impulse is equals to F into T means like this. Here delta P is equals to F into delta T. I will write here dP is equals to F into dt. That means that delta T is finite interval of time. This dt means infinitely small interval of time. So this t2 to t1 itself is small. In that I am considering a very small time interval. That time interval is dt. In this dt time interval, the very finite change in momentum is dp. Okay. Then in this small interval, although the force is variable, but the time interval is very small. So in this small interval, the force I can consider as constant force. Always remember, any physical quantity, if it is varying, with time. If we consider the time interval as very very small like dt, in that time interval that quantity we can consider as constant. Here dp is a small change in, infinitely small change in momentum. We want to find the total change in momentum. The total change in momentum means we have to apply integration on both sides, integrating on both sides. This integration we will study in mathematics. Okay, then this integration of dp becomes p, that is nothing but the total change in momentum, that we can able to represent as j. This equals to integral of f into dt. So here you can give some limits from time interval t1 to t2. Just formula wise you remember, now you will not understand this step. Okay, in this way also we can able to find the impulse for variable force. So this is about impulse. And next I said that I will give some example for impulse momentum theorem, right? And also remember, in the graph, if you consider this point is O, this point is A, this point is B, and this point is C, then here this area under ft graph. Okay, so here area under ft graph means I am considering this length is OB and this breadth is that is BC. OB into BC. In OB means that is nothing but F, and in BC that is nothing but T. F into T is nothing but change in momentum. F into T is nothing but what? Change in momentum. Then remember always the area under FT graph will gives the change in momentum. And what is that impulse momentum theorem? Impulse momentum theorem. So here in impulse momentum theorem, this J is equals to F into T. This is also equals to change in momentum, that is delta P. You can write it as M V minus U. So the impulse produces a sudden change in momentum. Why? Because the time interval is very very small, means the change in momentum is also very very fast. There will be a sudden change in momentum. And then some example we can give for this impulse momentum theorem. Let us consider here for a given change in momentum. Let us consider that change in momentum is 100 units. The time interval is, if you consider 1 second, in 1 second the change in momentum comes, that is 100 units. Then how much force is needed means definitely 100 Newton force is needed, right? So if you increase the time interval, then force acting on a body or an object will reduces. So now it will become 50. So still if you increase the time, still the force will decreases. That means for given change in momentum, this F is inversely proportional to T. As time interval increases, the force will decreases. So you can consider an example, that is a cricketer catches the ball. Okay, while catching the ball, he will brings his hand backward. Why? Because if he is not bringing hand backward means, imagine the situation, a ball is moving with some initial velocity u and it will strikes to the hand. So as soon it strikes to the hand, the final velocity becomes 0. How much time it takes from u velocity to 0 velocity means a fraction of second. That is sudden change in momentum. That sudden change in momentum creates more impact on our hand. So what we have to do means, in spite of keeping hand in the same position while the ball is coming, we have to pull our hand backwards. By doing that, the velocity suddenly not become 0. After some time the velocity becomes 0. It takes some additional time to make the final velocity 0. We are avoiding the sudden change in momentum. Then as we increase the time interval, then definitely the force acting on our hand decreases, or the impact on our hand will decreases. Okay, remember this example for this impulse. And then other example means an athlete, that means has to do a long jump. Let us consider he will jump on the mud, isn't it? Or an high jumper, he will jump on some spongy surface. They will not jump on concrete wall. So there also you can apply this concept. What happens means, on a concrete wall, on a concrete floor, if a player jumps means final velocity comes immediately to 0, isn't it? There will be a sudden change in momentum. Suppose if he jumps on spongy surface, then what happens? Slowly the final velocity becomes 0. It avoids the sudden change in momentum. Then impact on the person become less. These are the examples we can give for impulse momentum theorem. I hope you understood the concept of impulse. And one more thing, remember this SI unit of impulse. Okay, SI unit of impulse means that J is equals to F into T also we can write, or you can write it as change in momentum, isn't it? So here you can consider Newton's second, or you can consider this change in momentum is nothing but kg meter per second. So change in momentum means you have to apply momentum SI unit only, kg meter per second. This is the SI unit of impulse. And this dimensional formula, m L T to the power minus 1. This is the dimensional formula. Thank you.